Okay class, in this lecture we will see type of cubic crystals and their elements, okay, terminology related to cubic crystal. So firstly, the type of cubic crystal. What is cube? See, in cube we have all sides A, B, C equal. These are equal to each other and we will take it to be A, okay, and the angle alpha, beta, gamma, these are equal to 90 degree. Okay class, so if you find the volume of a cube, volume of a cube, it will be equal to, as you have seen in the previous lectures, it is given by scalar triple product. Okay, so it will be equal to A cube. Okay class, now here we will see where the particles are present in simple cubic, in body centered cubic, and what is it, how it is different from simple cubic, and FCC. Okay, so I am taking the simple cubic here. This is simple cubic. So here you will see this is Z direction, as we have seen earlier. This is the X direction, X, Y and Z. Along all three crystal axes, the particles are present at a distance of A. So this is primitive length of primitive translation vector. Okay, so the cube will be of this kind. This is the cube, you will see. This is the cube, it is like this. Okay class, so see where the particles are present here. One particle is present at this corner, one is here, another particle is here, one more particle is here, then here, here and here. So you can see the total number of particles present in the simple cubic, that is equal to number of the corners. So here particles are present at the corners. Okay, so in this the number of corners and number of particles is same. This is equal to number of particles. Okay class, and in BCC, now come to BCC. Here we have BCC. Okay, in BCC we have cube. This is the cube, you will see. This is the cube and particles are present at the corner. Okay, I am making circle with respect to the particles which are present at the corner, and one more particle is present at the body diagonal. You have seen this in the previous topics. This is the particle at the center of the body, totally inside the unit cell. Okay, the size of the primitive vectors here also, not primitive vector, the size of the side of the cube, it is again A. So the volume of the unit cell is A cube. Now the third type is FCC, where particles are present at the faces. Okay, so the last is FCC. So here the location of the particles is something like this. You will see that this is the cube and 8 corners are there. So here one particle at each corner. Okay, so the number of particle at corner, this is equal to 8. Okay class. And the number of faces, here you can see this is the top face, this is the top face, okay, and one face is just below it, so two face, and then you have another face, this face, you see this is the side face, okay, and another face is here, this is, so 4, and one face is in the backward direction, and this is the front face. So the number of faces, this is equal to 6. Okay class. And in face center, one particle is present at the face. The face diagonal, you will see, this is the face diagonal, okay, and at the intersection you have one particle. Here also you have one particle. On the back face, you have one particle. On the side face, you have one particle. On the bottom face, one more particle is, and on the front face, you have another particle. I am representing it by this. And one particle is present at the corner. So 8 corners are there. 8 corners are there. Number of particle at the corners, that is 8. And the number of particle present at the face is equal to number of the faces, that is 6. So 6 particles are on the faces. So this is how you can see where the particles are present in simple cubic, BCC and FCC. Now class C. Class, now we have to find how many effective number of particle present inside the cube. Okay, you know the crystal is a 3-dimensional structure, mean to say one more particle is present, one more cube is present after this side face, one cube is present after the backward face, one is present above it. So you can see this is 3-dimensional arrangement. Okay class, mean to say these particles, a particle which is present just inside the cell, that is shared by this cell only, and the particles which are present at the corner and at the face, these are also shared by other unit cells. Okay, so mean to say if I extend this unit cell, this crystal along this direction, then you will see a cube is also present, one more cube is here. Okay, now look at this face. I am talking of this face, and you see the particle which, if we assume it to be of spherical size, okay, like a sphere, then this sphere is shared by 2 cells, this one and this one. So I can say half of the sphere is present in this second cell and half of the sphere is present in the first cell. So here you can see the contribution, I will write here, the contribution of a particle in a unit cell, that is equal to of a particle at face in a unit cell, that is equal to half, because it is shared by 2 unit cells. Now come to the corner. I am taking example of this. If you see it in 3 dimension, then let me extend these. Okay class. So here you will see one cube is present at the side of this face. Okay, one is above this cube, one is behind this, and then above that, and one is above this top face. Okay, and towards your face. So this particle, it is shared by in total 8 cubes. Okay class. So this sphere is shared by 8 cube. So I can say the contribution of this particle, this sphere, which is present at the corner in a unit cell, in one unit cell, is 1 by 8. Okay, so I am writing here contribution of a sphere of or a particle at the corner in a unit cell that is equal to 1 by 8. Okay class. Now come to the body center. Here in BCC the particle is present at the corner. Okay, and here you have seen this particle will contribute 1 by 8 to this unit cell. Okay, and this pink colored particle is totally inside the body of the unit cell, so it is not shared by any other cell, and its contribution will be 1. Okay, so I will write here the contribution of particle at body center, this is equal to 1. Okay class. Now we are to find the number of atoms present in the unit cell. Okay, so come to this formula. Here I can write 1 times of Ni, number of particle present in the interior, and Nf, this is the number of particle present at the face, and you have seen the contribution of the particle at the face in a unit cell, that is half, and this is Nc, number of particle at the corner. So come to this cube. In all cubes, this corner is shared by 8 unit cells. So the contribution of the particle which is present at the corner, that is 1 by 8. That's why 1 by 8 is there. Okay, so this is the formula to count the effective number of particle present in the cube. I am writing it again here. The number of particle n. Okay, this is what? This is effective number of particle. In short, effective number of particle in the cell, that is equal to one time mean full contribution of the particle which is present inside. Okay, Ni is the number of particle which are present totally inside the cell. Then 1 by 2 times of the number of particle which are present at the face. Okay, so this is Nf plus 1 by 8 times of the number of particle which are present at the corner. Now come to this simple cubic. Here the effective number of particle, that is n, effective number of particle in a simple cubic. Okay, or I write it like number of particle in simple cubic. This is equal to, now see where the particles are present only at the corner. And how many corners are there? There are 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. So the number of particle present at the corner, this is 8. Okay class. And the contribution of one particle at the corner, it is 1 by 8. So the effective number of particle in simple cubic, this is equal to 1. Clear class? And here you can see, as the number of particle, effective number of particle in the simple cubic is 1, so that's why this is a primitive unit cell. I am writing here the simple cubic, this is primitive unit cell, and the volume of the primitive unit cell is a cube. You have done this in the previous lecture. Okay, now come to body centered cubic. So in body centered cubic, 8 particles are present at the corner and 1 particle is inside the unit cell present at the center of the body. Okay, so the effective number of particle n, number of particle in BCC, number of particle in BCC unit cell, this is equal to, see how many corners are there, 8 corners are there. Number of particles, I will write it like, I can write it, and see number of particle at the corner, and contribution of the particle at the corner is 1 by 8, and then plus number of particle in the interior, number of particle in the interior, and it is contributing fully inside the unit cell. So it will be equal to 1 by 8 times of number of particle at the corner, that is 8, and then plus number of particle in the interior, that is 1. So its contribution is full, so it will give you 2. Now see, BCC is not a primitive unit cell, so this is not primitive unit cell. BCC is not primitive unit cell. Okay class, because the number of particle is more than 1. So class, if you find the volume acquired by 1 particle, okay, or volume of the primitive unit cell, okay, volume of BCC, this is equal to a cube, and how many particles are there? 2 effective particles are there. So volume of 1 particle, it will be equal to a cube by 2. Okay, so in BCC the primitive unit cell will be that which is having volume a cube by 2. Okay class, now come to FCC. This is FCC. In FCC, particles are present at the corners, at the 8 corners and at the 6 faces. Okay class, so this is the picture. Okay, this is Y, this is X, and this is Z. So here 6 particles are present at the corner and 8 particles are present, 8 particles are present at the corner and 6 particles are present at the face center. So the contribution here will be, the effective number of particles will be equal to 1 by 8 times of the number of particles present at the corner plus 1 by 2 times of the number of particles present at the face. You see, no any particle is in the interior here, so no need to write that. So here we have, how many particles are present at the corner? This is 8 as you have seen, and the number of faces, it is 6, so I am writing here 6. So if you solve it, then you will see the number of particle, effective number of particle in FCC, this is equal to 1 plus 3, that is 4. So class, here see, in primitive unit cell the number of particle is 1 and in FCC the number of particle is 4. So FCC also not a primitive unit cell. This is also not a primitive unit cell. Okay, because the number of particle is more than 1. Okay, now see, if you find the volume of FCC, this is equal to a cube, because the size is a. Okay, this is a cube, all sides are equal and they are mutually perpendicular to each other, so the triple product of the vectors will be a cube. Now see, this a cube volume is shared by how many particles? 4. So if you find the volume of primitive unit cell, in case of FCC, this must be equal to a cube by 4. Okay class, so this is the next point, number of effective atoms in a unit cell, and this is the formula. Okay, okay class, now see, we have seen two elements of the cubic crystal. I think these are in detail, and the length of the video lecture is about 20 minutes, and if we discuss all these things, the length of the video will be about 40 minutes. Okay, so rest of the elements regarding cubic crystal we will discuss in the next video lecture. Thank you class.